Hello friends, welcome to Expert Guidance. Today in this video we'll be covering the section D, the periodic table of the topic 1, Principles of Chemistry of your Edexcel IGCSE Chemistry, and this video will be covering the specification 1.18 to 1.24. Now in this video we'll be looking over how the elements are arranged in the periodic table, how we can deduce the electronic configuration of the first 20 elements from their position in the periodic table, and how do we classify the elements as metal and non-metal, and how we can use their positions in the periodic table to predict certain properties of the elements. And we will also see how the elements in the same group have similar chemical properties and why noble gases do not react. Now, I would recommend you to watch this video till the end, because in the end, I'll also give you some key terms and the glossaries of the important terms which are used in this topic. So let's begin. Now, when we talk about the development of the periodic table, it took a lot of years to get the periodic table in the form which we have now. It started all around in 1808, where there was a scientist called John Dalton, and he published a table of elements, and he simply arranged the elements in the order of increasing atomic weights. There was no pattern, no similarity that was detected, so his idea was completely rejected. Then in 1864 came another scientist called John Newland, and he gave the Newland Law of Octaves. Now, what he did in that was he arranged the elements according to their atomic weights, and what he found that there was a similarity in the first element and the eighth element, like the octaves. Now, his idea was okay as it worked well up to calcium, but majority of the elements were not discovered at that time. So his idea of the first and the eighth similarity did not fit with all the elements. So that was also rejected. Then a biggest revolution came in 1869 when a scientist called Dmitry Mendeleev, he also arranged the elements according to atomic weights, but he found patterns of similarities within the elements because he left gap where the elements did not fit the pattern. So in this way, he organized the similar elements in the similar groups, and where the gaps were left, they gave us the pathway to discover the new elements. And using his idea, there were many new elements that were discovered. But again, that was not that effective because not all elements fit into that pattern. So argon, it was one of the shortcomings that argon, which had a relatively greater mass than potassium, should be placed before potassium. But if we do like this, then the argon will be placed in the group of sodium, and lithium and potassium will come in the groups of noble gas. So that is not a trend in the properties. Many other elements were also found not fitting this pattern, and Mendeleev swaps them in order to maintain the periodicity, but his periodic table was not universally accepted. Now, the present periodic table now overcome all these shortcomings by organizing the elements in the order of increasing atomic number or the proton number. So all the problems that were due to dissimilar atomic weights were all corrected by this. And when we created the elements in the form of atomic number, we came to know that the difference in masses of some of the elements is due to their isotopes, because there are many different isotopes an element can have, and the atomic mass is the average of the isotopic mass of all its isotopes. Okay, so this is how we came to this form, which is a present periodic table. Now, just looking at this modern periodic table, there are a lot of things that you can easily find out. First of all, from this group 13, we will make a zigzag like this staircase. All the elements that comes into the zigzag are metalloids or the semi-metals. All the elements which are left to that are all metals, and the elements to the right are the non-metals. So if someone asks you, give an example of any metal, you can pick any one from this group. If somebody asks you, give an example of a non-metal, you can easily pick any from this group. What is a metalloid? You can easily pick one in this
zigzag. Now, the last group is a noble gas. Now, we'll see when we do the electronic configuration of the noble gas that it has full outer shell electronic configuration. As a result, noble gases are given the name noble gases because they do not react. The elements in the same group will have the same number of electrons in their outermost shell. So in the group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all of them have 1 electron in their outermost shell. Beryllium, magnesium, this whole group have 2 electrons in their outermost shell. This group has all 3 electrons in its outermost shell. So from the group number, you will get to know the information that these elements have these many electrons in the outermost shell, and if 2 elements have the same number of electrons in the outermost shell, it means they have similar chemical properties. Now, the next thing you need to remember from this periodic table is what are the common names of certain groups. Now, group 1 is known as alkali metals. We'll find out why they are known as alkali metals. Group 2 are known as alkaline earth metals. Group 7, that is whole of this group, is halogens, and group 8 or group 0 or the last group of the periodic table is a noble gas. And the elements which are between group 2 and group 13 or group 2 and group 3 are known as transition metals. Okay, now in the exam they can give you the periodic table and then ask you to give an example of a transition metal, a metal, alkali metal, noble gas, alkaline earth metal. So just looking at the periodic table, there's nothing to memorize in that. You can easily give the answer. Okay, now if you see, majority of the periodic table can be categorized into 2 classes of elements, the metals and the non-metals. Now you should know what is the difference between a metal and a non-metal. 2 differences I can easily make from the periodic table. There are a lot of metals than the non-metals. Metals are to the left of the periodic table, non-metals are to the right of the periodic table. Now let's look at what are some physical differences we see in metals and non-metals. When we talk about the appearances, metals are very shiny and lustrous like gold, platinum. The non-metals are dull in appearance. The position is metals are found in the left, non-metals are found to the right of the periodic table. Metals are good conductors of both heat and electricity. We'll see in metallic bonding that they have delocalized electrons, which make them very good conductors of heat and electricity. On the other hand, non-metal have no ions, no delocalized electrons, nothing to conduct electricity except graphite. So non-metals are considered as insulators. Then there are 2 very important properties, which is malleability and ductile. Malleable is hammering them into sheets and ductile is hammering them into wires. So metals are malleable and ductile both. So you can hammer them to sheets and you can also draw them to wires. But you cannot do that for non-metals. So non-metals are not at all malleable and not at all ductile. Next, all the metals, they lose electron to form positive ions. We'll see in ionic bonding. And you also know that the metal has like 1, 2 or 3 electrons in the outermost shell, which is easier to lose. On the other hand, non-metals have more than 5 electrons in their outermost shell, so it's better for them to gain an electron. So they gain an electron and form the negative ions. Now, the density of the metals is very high and they also have high melting and boiling points, whereas non-metals have a low density melting and the boiling points. Now, the examples of the metals are sodium, potassium, that is group 1, 2, and 3 elements, and non-metals are carbon, sulfur. So group 4, 5, 6, 7 are all non-metals. Okay, so now let us see, as I told you, the common groups, and you need to remember what these group number known as. So group 0, 1, 2, and 7 is what you should know. Group 0 is noble gas, 1 is alkali metal, group 2 is alkaline earth metal, and group 7 is halogens. Now, group 0, why is it called as a noble gas? Because they are stable, they have full outer shell, therefore they do not react. So what will be the properties of group 0? They are stable, unreactive, have full outer shell configuration, and are found in the last group, that is to the extreme right. Example, helium, neon, argon, krypton, xenon, and radon. Group 1 are alkali metals. We call them metals because they show all the metallic properties, and we call them alkali because they all react with water to form metal hydroxide, which is an alkali. Now, what are alkalis? Alkalis are the bases which can dissolve in water. So soluble bases are alkali. So what will be the properties of alkali metals? They are reactive. They have 1 electron in the outermost shell. They lose 1 electron to form positive 1 ion and gain full outer shell configuration by losing 1 electron. Example, list all the elements which are to the extreme left. And what are they? Lithium, sodium, potassium, rubidium, cesium, and francium. When we talk about group 2, these are alkaline earth metals. Alkaline, the reason is the same. They also react with water to form metal hydroxide. But why we call them earth metals? Because they're majorly found in rocks. And again, they have properties like the alkali metals. They are reactive, but they do not form +1 ions. They form +2 ions because they have 2 electrons in the outermost shell. So they lose 2 electrons to gain positive, to form positive 2 ion stable configuration. Example, beryllium, magnesium, calcium, strontium, barium, and radium. For group 7, it's halogens. Why we call them halogens? Halo means salt, gen means forming. So they are salt forming. They combine with metals and form salt. They have 7 electrons in the outermost shell. And as they have 7 electrons in the outermost shell, they just need to gain 1 more to have a full noble gas outer configuration. So they form negative ions. Example, fluorine, chlorine, bromine, and iodine. We'll discuss in a little bit more detail about group 1 and group 7 in this video. But all these halogens, they exist as diatomic molecule. So in the reaction, you will never see as F. You will see it as F2. You will never see Cl. You will see it as Cl2. Okay, so I hope this table is clear to you. This is very important. Make sure you remember the common names, which group they are in, why we call them with their names, and few properties of them. Okay, so now let's elaborate about group 1 and group 7 a bit. Now, when we talk about group 1, these are all the elements: lithium, sodium, potassium, rubidium, cesium, and francium. That is their symbol. You can easily see from the periodic table. And this is their electronic configuration. So lithium is 2,1, 281, 2881. Now you can notice all of them have 1 electron in their outermost shell. Therefore, they all belong to group 1. Okay. Now, their reactivity increases down the group because all these elements react by losing an electron. And when you go down the group, the tendency to lose an electron increases. Now, why it increases, we'll just find out. So, if they'll ask you in the exam, which is the most reactive group 1 element, you can easily say cesium and francium. Francium is radioactive, but it is highly reactive. And then, which is the least reactive alkali metal? That is lithium. Out of sodium and potassium, which is more reactive, you can easily say potassium because it is down the group. Down the group, the reactivity of group 1 metals increases. Okay, now let us look at the physical properties of group 1. They are highly reactive. Their reactivity increases down the group. Since they have 1 electron in the outermost shell, they lose 1 electron and form positive 1 ions. They are stored in kerosene and oil. Why? Because they are highly reactive. They can easily react with air, oxygen in the air, or moisture in the air, and can cause an explosive reaction. They are soft, silvery, and shiny, but you must have seen that the metals at times look dull. The reason for that is they react with oxygen in the air, as they're too reactive, and forms a layer of oxides on its surface, and that oxide gives them a tarnish appearance. And I've already told you that lithium is less reactive and francesium is highly reactive. They have low melting in the boiling points, and the melting in the boiling point decreases down the group. Okay, so I hope these physical properties are clear to you. Now let us look at the chemical properties. Now in the chemical properties, you need to know about 3 reactions. Reactions with water, reactions with oxygen, reaction with halogen. Now always remember, whenever asked in the exam, you'll be writing a balanced chemical equation along with the state symbols. So here I'll be taking an example of lithium, how lithium reacts with water, oxygen, halogen. You can replace lithium with any of the group 1 element, that is lithium, sodium, and potassium, and write the equation the same way. So whenever any metal, that is M, group 1 metal, that is lithium, sodium, and potassium, reacts with water, it forms metal hydroxide. MOH is the formula, plus hydrogen. So if I take M with lithium, lithium with water form LiOH plus hydrogen. Remember, lithium is a solid, water is a liquid, lithium hydroxide is aqueous, and hydrogen is a gas. Now the question can come, what is the observation of this reaction? So you can easily say that we will see that the solid is decreasing in size or mass. And since there is a hydrogen being produced, which is a gas, we'll see the fizzing. Okay, and they can ask you the test for hydrogen. So it's a squeaky pop test. Okay, so metal hydroxide is formed, which is an alkali, and therefore they can ask you what will be the pH. So there'll be an increase in pH. And remember, the reactivity increases down the group. So potassium will react more violently as compared to lithium. When we see the reaction with oxygen, it forms metal oxides. And for the group 1 oxide, the formula is M2O. So lithium oxide is Li2O, sodium oxide is Na2O. We'll see in bonding how we determine the formulas of the ionic compound. But till then, you can just remember that group 1 oxides will be of the formula M2O. So lithium, which is a solid, reacts with oxygen, which is a gas, and it forms 2Li2O, which is a solid. Okay, and when we react it with halogens, you get the metal halides. Okay, so like lithium with fluorine, remember halogens will be in the form of diatomic molecule, and it gives lithium fluoride, which is a solid. Okay, so these three reactions, very, very important. Make sure you remember them. Make sure you know how to write the equations along with the state symbols, and do not forget to balance the equation. Okay, now, as you know, the reactivity with the water will increase down the group. So when you have the reaction with potassium, we will see that there's a fizzing, and there's a very violent fizzing, and the potassium will quickly melts into a ball and catches fire and produces a lilac flame. Whereas sodium will react a little bit intermittently, and all of them, lithium, sodium, potassium, as I told you, alkali metals have less density. We'll see both of them will be floating in water. Okay, all of the three will be producing fizzing because the hydrogen is being released. In lithium, since it is not that reactive, the shape is retained and it quickly, slowly gets smaller. Whereas in sodium, it melts into a ball while reacting. So it will get deformed earlier than lithium. And potassium, it quickly melts into a ball, catches fire, and produces a lilac flame. This observation can also tell you that the one that is reacting very explosively is one of the elements which is down the group. Okay, so I hope the physical properties, the chemical properties, and what is the electronic configuration of group 1 is clear to you. Now comes a very important question. Why the reactivity of group 1 increases down the group? Okay, now, in order to explain that, you need to remember that if any question comes in, you need to first explain that alkali metals, they react by losing electron, and the tendency to lose the electron increases down the group, therefore they become more reactive. Now the question is, why it increases down the group? Now, the tendency to lose an electron depends on these three factors, and all these three factors contributes to an increase in tendency of the alkali metals to lose an electron down a group. First is the nuclear charge. Now, if the nuclear charge will be smaller, the outer electron will be weakly held by the nucleus and can be lost easily. So once we go down the group, you have seen, if you see the electronic configuration of the group 1 elements, can you see that the shells are increasing? So there are more electrons that are being added. So the atom is getting bigger in size. As the atom is getting bigger in size, the outer electron is getting further away from the nucleus. So as the outer electron is getting further away from the nucleus, the nuclear charge decreases. The inner electrons, they are shielding the outer electron from whatever nuclear charge that is present, and bigger the size of the atom is also decreasing the nuclear charge. So due to all these factors, down the group, the tendency to lose an electron increases, and alkali metals react by losing an electron. Therefore, the reactivity of group 1 increases down the group. Okay. Now remember, when you get this question, you need to talk about these scientific terms, the nuclear charge, shielding, and size of the atom. Okay, so I'll summarize. Down the group, the atom size increases due to increase in the number of electronic shell. This results in the outer electron being further away from the nucleus. As the outer electrons become further away from the nucleus charge decreases. Increase in number of shells also increases the shielding and shields the outer electrons from the nuclear charge. Therefore, the tendency of an atom to lose an electron increases down the group, resulting in increase in reactivity down the group. Okay, so remember, in group 1 you need to know the reason why it increases, the reactivity increases down the group, and I hope now you're able to answer that. Okay, now the next thing we need to do is group 7. As I told you, group 7 are known as halogens, and halogens are known as salt forming. Okay, now what is the electronic configuration of halogens? So electronic configuration is that they all have 7 electrons in its outermost shell, and when they have 7 electrons in this outermost shell, they can easily gain 1 electron to gain the full outer shell configuration. And when they gain these 1 electron, what will happen? They will form the -1 charge. So these all react by forming the -1 ions. So the members of the halogens are fluorine, chlorine, bromine, iodine, and astatine. Electronic configuration 27, 287, 28, 187, 288, 1887. So you can see all of them have 7 electrons in this outermost shell. Now you also need to know what is the physical state, like how do they look like at room temperature and how do they look like in solution. So the fluorine is a yellow gas, chlorine is a green gas, and if fluorine is in solution, that if there's any reaction that results in the formation of chlorine in a solution, then it will give a pale green color. Bromine is a volatile brown liquid, but if bromine is in the form of bromine water, it will be yellow colored solution. Iodine is a volatile purple solid, but if it is in solution, it will form a brown solution. And astatine is a radioactive halogen. Again, as we discussed in group 1, the group 7 has an opposite trend in reactivity. So group 7 reactivity decreases down the group. Why? Because they react by gaining an electron and the electron affinity decreases down the group. Okay, we'll see it in detail in the next 2 to 3 slides why it happens. But if the question comes in the exam, which is the highly reactive halogen, so you should quickly answer fluorine, which is the least reactive, astatine, which is more reactive than bromine, chlorine, which is less reactive than bromine, iodine, which is a green gas amongst halogen, chlorine. So you should know about all of this. Okay, so now let's talk about the physical properties. We all know they are nonmetals, found to the right. They gain an electron from -1 ions. They have low melting and a boiling point, and their melting points and boiling point increases down the group. I already told you they exist as diatomic molecule. They are poisonous and smelly. Their reactivity does not increase down the group. The reactivity decreases down the group. Their density increases down the group, and they are poor conductors of heat and electricity. Okay, now let's talk about their chemical reactions. When they react with hydrogen, they form hydrogen halide, and these hydrogen halides, if you have a fluorine, chlorine, the reaction will be more explosive because these are highly reactive down the group. To have this reaction with iodine or maybe bromine, you might require a catalyst. When they react with metals, they form ionic compound. They gain 1 electron from the metals and form this noble gas electronic configuration. These ionic bonding will be discussed in more detail in the structure and bonding unit. Okay, now this is a very, very important reaction, which is a displacement reaction. And this is the only reactions in halogen which require a bit of an understanding. It's easy if you understand it properly. Now, what happens is a more reactive halogen will take the position of the less reactive halogen in its salt. Okay, now what is the most reactive halogen? The halogen which is at the top will take the position of the halogen at the bottom, provided the bottom halogen should be in the form of a compound. So for example, if you look at this reaction, chlorine with NaBr, which is more reactive? Chlorine, good. Which is less reactive? Bromine. And bromine is in the form of compound or salt. So chlorine can quickly swap the position of the bromine and form 2 NaCl and displaces the bromine. And if you remember, if this reaction is in solution, you will see a yellow solution. Okay, so chlorine is being more reactive. The salt is of the less reactive halogen. So chlorine being more reactive has taken the position of the less reactive bromine in its compound. And bromine gas being less reactive than chlorine has been displaced by chlorine. On the other hand, if you do this reaction, chlorine with NaF, which is more reactive? Fluorine, is it alone? No, it is in the form of compound. So nobody can take its position because it is the highly reactive, so no reaction. So fluorine can displace all the halogens, chlorine can displace all except fluorine, bromine can displace only iodine, and iodine cannot displace fluorine or chlorine or bromine. Okay, so remember, the top halogen can take the position of the bottom halogen, provided the top halogen should be alone and the bottom halogen should be in the form of an element or a compound. Okay, sorry, compound or in the form of a salt. Okay, so I hope this displacement reaction is clear to you. Next is, again, as group 1, why the reactivity of group 7 increases down the group. So to answer this question, you will first explain how group 7 reacts. So group 7 reacts by gaining electron, and down the group, the electron affinity decreases. Therefore, the reactivity down the group decreases. Now, why the tendency to gain an electron decreases? Again, we'll be talking about these three scientific terms: nuclear charge, shielding, and size of the atom. As you go down the group, the nuclear charge decreases because of the increase in size of the atom. So the halogen cannot hold the incoming electron properly. So it won't be able to gain an electron with that ease down the group. Also, down the group, the nuclear charge gets shielded by the inner electron. So the incoming electron will experience a smaller nuclear charge. Okay, so I hope it's clear to you. Now let me summarize. Down the group, the atom size increases due to increase in the number of electron shell. As a result, the nuclear charge decreases. The size of the atom also increases down the group, which makes the nuclear charge weaker. The electron shells also increases, which decreases the effective nuclear charge on the incoming electron. So due to all these factors, the nuclear charge decreases, which decreases the tendency of gaining electron down the group of halogen, making them less reactive. Okay, so to summarize, we talked about group 1, group 7. These are alkali metals, these are halogens. They have 1 electron in the outermost shell, they have 7 electrons in the outermost shell. They are metals, they are non-metal. They react by losing an electron, they react by gaining an electron. They form positive 1 ion, they form negative 1 ion. The alkali metal reactivity increases down the group, and the group 7 halogen reactivity decreases down the group. The group 1 reactivity depends on the tendency to lose an electron, and group 7 halogen tendency depends on gaining an electron. Therefore, reactivity of group 7 decreases down the group, but for group 1, it increases down the group. Okay, now let's do the last topic, transition metal, which is a chemistry only topic. Transition elements are found in group 2 and 3. So this block is a transition metal. They are hard, they are strong, they are malleable and ductile. They have higher density than group 1 and group 2. Therefore, iron you have seen, copper you have seen is used in construction purposes. They are used commercially as a catalyst. They show variable oxidation state. They form colored compounds, okay? And they show the reaction of oxygen, water, and halogen like group 1, but they react slowly, so they do not corrode easily, okay? So I hope the periodic table is clear to you. Now let's quickly brush up the key terms that we saw in this unit. We discussed about the periodic table, metals, non-metal, halogens, alkali metal, noble gases, transition metals, periods, group, alkali, and the displacement reaction. Now, what is a periodic table? A periodic table is a table that shows an arrangement of all the known elements in the order of their increasing atomic number or a proton number. And the table is organized into periods and groups. Metals are the elements found in the left of the periodic tables, which are sharp, shiny, conductors, malleable, and ductile. Example, group 1, 2, and group 3. Non-metals are the elements found to the right of the periodic table, which are dull, insulators. Example, group 4, 5, 6, and 7. Halogens are group 7 elements as they are salt forming. Alkali metals are group 1, which react with water to form alkali. Noble gases are group 0 elements, which are stable and do not react as they have complete outer shell. Transition metals are the elements found between group 2 and group 3, which have high density, show variable oxidation states, and form colored compounds. Periods are the horizontal rows of the periodic table. Groups are the vertical columns of the periodic table. Alkalis are the bases that are soluble in water. And displacement reaction is when a more reactive element displaces the less reactive element from its salt solution. Okay, so all these key points are clear to you. Now let's test yourself. Now you need to look at the periodic table and give me 2 examples of each. a nonmetal, alkali metal, halogens, noble gases, semi-metal or metalloid, metal that form +1 ion, metal that form -1 ion, metal that form +2 ions, and a transition metal. Next is you need to write the name of the most reactive halogen and the most reactive alkali metal, why alkali metal gets more reactive down the group, why the halogen gets less reactive down the group, and then you have to write the balanced chemical equation, including the state symbols of potassium with water, lithium with oxygen, sodium with bromine, chlorine and hydrogen, and then you need to explain the displacement reaction of halogen with example. So you can pause the video, have a go at these questions. If there's still any question you're unable to answer, go back, look over the video again. Okay, so now let us look at the answers. So metal, these are just my answers. You can pick any. So there's no right and wrong here. Metal, there are so many metals. You can list any metal. But remember, they should be from the left of the periodic table. Non-metal, oxygen, fluorine, alkali metal, group 1, halogens, any metal from group 7, noble gas, group 8, semi-metal or metalloids, remember that zigzag, all the elements that come in the zigzag, you can name that, so that is silicon. Metal from +1 ion, it means they have 1 electron in the outermost shell, so any of the group 1 example. Non-metal that form negative ions means it should have 7 electrons in the outermost shell, so any of the halogen. Metals that form +2 ions should be group 2, so any of the group 2 you can name. Transition metals are the elements between group 2 and group 3, so you can give any example from that. Okay, so I hope you are now clear with how to read the periodic table. The most reactive halogen, remember, is the halogen which is the top one, that is the fluorine, and the most reactive alkali metal is the bottom one, which is the francium. Why the alkali metal goes more reactive down the group? I know you know the answer. So down the group, the atomic size increases due to increase in number of electronic shell. This results in the outer electron being further away from the nucleus. As the outer electron becomes further away from the nucleus charge decreases. Now, increase in number of shell also increases the shielding and shields the outer electron from the nuclear charge. Therefore, the tendency of an atom to lose an electron increases down the group, resulting in increase in reactivity of the alkali metals down the group. On the other hand, halogens down the group, the atomic size increases, again due to increase in number of shell. The nuclear charge decreases, the size of the atom also increases, decreasing the nuclear charge, and the shells also shields the outer electron from the nuclear charge. Therefore, the incoming electron cannot be held with a stronger nuclear force. Due to all these factors, the tendency to gain an electron or electron affinity decreases down the group. Therefore, the halogens become less reactive down the group. Okay. Next is write the chemical reaction, potassium with water, KOH plus hydrogen. Remember, there'll be a fizzing. It's an alkali, so the pH increases. Lithium with oxygen is lithium oxide. It can form the layer and make the metal look dull. Sodium with bromine is a sodium bromide, ionic compound. We'll see dot and cross diagram in the bonding chapter. Chlorine with hydrogen form an HCl gas. Explain displacement reaction when the more reactive halogen displaces the less reactive from its salt. So fluorine being more reactive is alone can displace the less reactive which is in the compound and itself form a compound and displaces the other one, so that is chlorine. But if we do it in the other way around, chlorine being less reactive cannot take the position of NaF, so no reaction. Okay, so I hope this chapter is well clear to you. Now what is the next step? Check the specification, make sure everything which is there in the specification is crystal clear to you, and do the exam questions on this chapter. The exam questions on this chapter can be found on my website. The link is mentioned in the description box below. I hope you liked the video. If you like the video, then do please comment on this, do like, and also click the bell icon so that you will come to know the upcoming videos and you will get a quick notification of the videos that I'll be uploading. If there's any if you've really found this video helpful and want me to make more videos on the topic of your choice, then leave a comment below with the topics you want, and I'll make sure and I'll try my level best to put that up before your exams. Okay, now do go over the chapters, and if there's anything that you still do not understand, leave a comment below or come to my website. There's a 24/7 chat support. I'm available all the time during your exam time to answer all your queries. Okay, so I'll see you next in the next video where we'll be covering the next chapter, and I look forward to your comments on how you find this video and what's the next video you want. Till then, happy revising.